Okay, these are some more problems from P3. And this is number 33. And we're just adding. And remember, in order to add radicals, they have to have the same index and the same radicand. And these have the same index, which is understood to be 2, just the square root. So you've got 7 of these plus 6 of those. Now you can write it and use the distributive property, 7 plus 6 of those, which is 13. So 13 square roots of 3. On number 36, again, we have the same index, which is 2, and the same radicand, which is 13x. So again, 4 of these minus 6 of these, which is negative 2 of these, and these are the square root of 13x. Okay. Let's take a look at number 39. Now this is a little bit more complicated. These have the same index, but they don't look like the radicands are the same, but we always have to make sure everything is simplified, and I do have a perfect square factor of 50, so we're in violation of no number 1, no perfect square factor of the radical. So 50 is the same thing as 25 times 2x, and I have a perfect square factor of 8. 4 is a perfect square, so 4 times 2 is 8. So I'll rewrite that. And what's the square root of 25? Should underline this. The square root of 25 is 5, so that comes out. And the square root of 4 is 2, so those come out there. So you can see that. Hope that makes sense. Okay. And then I've got 5 of these minus 2 of these, so 5 minus 2 is 3, so I got 3. If I didn't do this step, it's kind of an extra step. You don't have to do it. So 5 things minus 2 things, 3 things. Okay, over here number 42. Again, we're adding or subtracting. We're subtracting. We have to have the same index, which is 2. And the same radicand. Now we don't have the same radicand, but I do have perfect square factors, so I can simplify these. So a perfect square factor here of 12 is 4, so I can write 12 as 4 times 3, and a perfect square factor 75 is 25. 75 is the same thing as 25 times 3. And then I can bring these out. Now be careful here. That's why I use the red underlines. What's the square root of 4? 2. So the 4, when I take the square root of it, it comes out, it becomes 2. What's the square root of 25? 5. So I bring that out. And then I just multiply what's 4 times 2, 8. And what's 2 times 5? 10. And then I got 8 things minus 10 things is negative 2 things, or negative 2 square roots of 3. Okay, number 45. This was just the square root of 1 over the square root of 7. And again, we have a radical in the denominator. I think that was a violation of no number 3, so I've got to rationalize that. So I just multiply the top and the bottom by just whatever will make that into a perfect square easy enough. And the square root of 7 does that. So I got 1 times the square root of 7, and the square root of 7 times the square root of 7 is the square root of 49, which is 7. Okay. And 48, I got the square root of 7 over the square root of 3. Again, I want to get a perfect square in the denominator. I want to rationalize the denominator. And the easiest way to do that is multiply by the square root of 3. Because the square root of 3 times the square root of 3 is the square root of 9, which is 3. And if I multiply the bottom by the square root of 3, I have to multiply the top by the square root of 3. And again, the square root of 7 times the square root of 3 is the square root of 7 times 3, which is 21. Okay? And here's 51. Now this is where we have a binomial in the bottom, so we have to use the conjugate. So the conjugate is just the same thing as the binomial, but with the opposite sign in the middle. So this is a negative in the middle, so I put a positive in the middle. So this is the conjugate. So I multiply the bottom and the top by the same thing. You remember, this is like a unit fraction. If the bottom and the top are the same, we're multiplying by 1. And if you multiply anything by 1, it stays the same. So the top, I just multiply 7 times this. There's not much I can do. And the bottom, now remember, this is like a minus b times a plus b, which is a squared minus b squared. If we multiply this out using the FOIL method, all right, we'd be multiplying first term times first term, square root of 5 times the square root of 5 is 5, the square root of 25, which is 5. And then the outside and the inside terms cancel. And then we have negative 2 times positive 2 is negative 4. Or you can just think of this squared minus that squared. Okay, and what's 5 minus 4? 1, so that's all we have. That makes sense. Okay, and then 54, same thing. 11 over the square root of 7 minus 3. We're going to multiply this again by the conjugate. So the top, we just multiply 11 times this. There's not much we can do with that. And then here again, we've got like, we're going to use the FOIL method. We've got a binomial times a binomial. I didn't really put parentheses, but we could if we wanted to, just for completeness. And we're going to multiply this out. Could have done the same thing on 51. Okay. And again, we use the FOIL method, and the square root of 7 times the square root of 7 is the square root of 49, which is 7. And then this is going to be positive, the square root of 21 minus the square root of 21, they cancel. And then I got negative, the square root of 3 times the square root of 3 is 3. All right, and then 7 minus 3 is 4. And there's your final answer. Okay. Hope those make sense.